Okay, so we might be asked to simplify some fraction, some fractional equality, some fractional inequality. For example, 2x over x plus 2 plus 2 over x equals 1 over x squared. Okay, so this might seem quite complicated, but in reality, let's have a look at this when we're talking about numbers as opposed to algebra. Okay, so we need to find a common denominator, as you would with numbers. So if we were adding 2 over 3 and 3 over 4, we multiply the denominators by each other to guarantee us that we have a common denominator, and we find what each of these numerators on top will be over that new denominator. So that's how we're going to work this algebraically. So if we did this with our numbers, what happens here is 2 over 3 becomes a fraction of 12. So to do this, we're going to multiply by 4 over 4. So to get 12, we multiply 3 by 4, and we do the same on the top. So that will give us 8. 8 over 12 is 2/3. Okay, so again for this, 3 over 4. To get 12, we can multiply the bottom by 3. So we also multiply the top by 3. That gives us 9 over 12. So that's similarly how we're going to do this algebraic. So to do that, to find a common denominator for the entire equation, we need to find the product of all three. So we're going to multiply everything along the top. So cancelling all the terms, we can cancel out the x plus 2 here, x plus 2 here, and so on going across. What we'll end up with is this here. So this could be a quartic equation by the looks of it, and we can solve this using a number of different methods, but we don't need that at this level of maths. So moving on to inequalities, this up here is a less than sign. So that states that if you have a number on this side, on the left hand side of that symbol, then that symbol, then the number over here is bigger. 3 is less than 5. Conversely, this over here is a greater than sign, so you can have 5 greater than 3 in that case. Do note that this symbol here denotes greater than or equal to. Solving inequalities. You can treat an inequality just as a normal equation as if there was an equals there, except in the case where you're multiplying or dividing by a negative number. So here we have x plus 2 is less than 3. To solve this, you can move the 2 across and that becomes a negative, or you can subtract 2 on both sides, whichever method you prefer to use. That will leave us with x is less than 3 minus 2, which is then x is less than 1. Moving on to something a little more complicated, 2x plus 3 greater than 9. Subtract 3 on both sides, you're going to have 2x greater than 9 minus 3. That's going to be 2x greater than 6. Divide across, or on both sides, by 2, and then you're going to end up with x is greater than 3. Down here, minus x less than 3. Now it is a simple example, but minus x less than 3, if you divide across by minus 1, you're going to end up with x less than minus 3. But when we divide or multiply by a negative number, we always have to flip the sign of the inequality, so this less than becomes a greater than down here. A slightly more complicated example, 2 minus x greater than minus 6. That becomes bringing 2 across, making it negative, or subtracting 2 on both sides. You'll end up with minus x greater than minus 6 minus 2. Minus x will then be greater than minus 8, so when you divide across by the minus 1, you're going to end up with x on the left, 8 on the right, but this greater than now becomes less than. So our x is less than 8. Finally, we have an example where we have two inequalities on both sides. So what we're going to do here is we're going to let this part be a single equation and this part be a single equation. You just need to divide by 2 on both sides. You'll end up with 2 less than x less than 3. Slightly more complicated example. Again, let this bit be a singular equation. Let this bit be a singular equation. So then you can just subtract 2 on both sides. You're going to end up with 3 minus 2. Now on to a slightly more complicated example. If we divide everything across here by minus 1, we're going to end up with 2x. We're going to end up with minus 4x squared minus 2x less than 8x. having divided by minus 1 and multiplied by minus 1, whichever one you consider that to be the way you do it, we now need to swap the direction of the inequalities. So we now have greater than symbols in each case. Now, we can do this either two ways, separate it out into two equations like so, or we can simply divide over and back the same way in each direction. So I'm going to do the second one, just for brevity. So if we divide everything by 2x, that will leave us with 1 on this end. Now minus 4x squared divided by 2x is going to give us minus 2x. This here will give us minus 1, and that will be greater than 4. Now, if we add 1 on each side, we're going to get 1 plus 1 greater than minus 2x greater than 4 plus 1. We then get 2 greater than minus 2x greater than 5. We divide everything across by 2, we're going to get 1 greater than minus x greater than 5 over 2. And finally, to complete this, we need to divide across by minus 1 to get rid of the minus in this part of the inequality. So that's going to give us minus 1 greater than x greater than minus 5 over 2. So again, we can rearrange this. We can just flip the whole thing around. Minus 5 over 2 will be here, and that will be less than x, because if you read this direction, this says that minus 5 over 2 is less than x, and x is less than minus 1. And that's our final answer. Next thing I want to discuss is plotting these on the number line. So say, for example, we've gotten a result stating that minus 2 is less than x is less than 4. We're told that this is an element of the naturals. Now, the naturals, they're all positive whole numbers. You may also be told that it's an element of the reals. Looks like this. Now the reals, all numbers possible. So every number you can possibly think of is a real number. You might be told that it's an element of Q. Now Q is the rational numbers. Rational numbers are anything that can be written in the form a over b. So things like pi, which are an endless sequence of random numbers, they can't be written as a fraction. But things like 5 over 3, 6 over 7, these are numbers that can be written as fractions, so they're rational. Lastly, though you may not ever come across it, you may be asked what this here is. This is the real numbers less the rational numbers. This less than coming from our sets chapter. Now, this here is the irrational numbers. This here is the set of numbers that can't be written as a over b. So you can't write it as a over b. So, for example, pi will be one of those numbers. The number e is also one of those numbers. That's roughly equal to 2.7. This is an element of the naturals. We can draw out our number line. Now we start in minus 2, minus 1, 0, 1, 2, 3, and 4. So, where do we put our dots? So we know that we're talking about an element of the naturals in this case. So for the naturals, they're all the positive whole numbers. They're all the numbers that are greater than 0 that are whole. That means 1 is included, it means 2 is included, 3, but not 4, because it's less than 4, not less than or equal to. That's crucial to remember. Let's consider that we're told that it's a member of the reals. In this case,
what are we talking about? So if it's a member of the reals and it's greater than minus 2 but less than 4, then we're not including minus 2 and 4. So in that case, what we have to do is exclude those two numbers. Between the two, though, every number is counted. So to denote this, we're going to draw in a thick bar as we go across. That tells us that every single number between minus 2 and 4, non-inclusive, is included in the set. If we're talking about integers, we're talking about positive and negative whole numbers. So what does this count as? Well, we have minus 2. It is not equal to minus 2 or 4, but it's less than 4 and greater than minus 2. The integers that we're talking about are these numbers here. Whole numbers that can be negative or positive. 0 is included.